Hello everyone, Patrick Clayton here with another discussion video. Today we're going to be trying to find the horizontal or oblique asymptote of a function. For today's question, I'm going to go over the function x squared minus 5x plus 2 over x minus 3. So when we're looking at horizontal or oblique asymptotes, a good general background is we look at the function, and what we care about is the highest term in each of the numerator and the numerator and the denominator. So in the numerator, we'll have some highest order term. And we just determine the order of the term by the highest exponent, essentially. And the same for the denominator. We're going to compare those two. So we're looking at the exponents of the highest order term in the numerator and the denominator. If the one in the denominator is larger than the one in the numerator, we will have a horizontal asymptote, and it will be the line y equals 0. If we have the case where n and m are the same, we will also have a horizontal asymptote, and it will be equivalent to y equals, and it'll be a fraction based off the coefficient of those terms, a over b. So as they sit in the equation, the horizontal asymptote will be the line y equals a over b. And then in the third scenario, if n is exactly 1 higher than m, so the numerator is 1 higher than the denominator, and it has to be exactly 1 degree higher, then we have an oblique asymptote. If it's more than 1 degree higher, it won't be a linear asymptote. So generally, we don't get into those in this class. So when we have the oblique scenario, we need to do either synthetic or long division to find the equation of that linear asymptote. So looking at ours, we have a 2 as the highest degree in the numerator and a 1 in the denominator. So we do indeed have this third case where you have an oblique. So synthetic division tends to be a little easier if you know how to do it. I'm going to go over the long division just to show the process I do for it, and I think this is the one students struggle with more. So it's the one I'm going to go over. So we are going to do a long division. We're going to divide the numerator by the denominator, and the result of that will be the equation of our oblique asymptote. So we're going to start out with x squared minus 5x plus 2 divided by x minus 3. So I like to do this in a very formulaic way. There's a lot of steps. It's easy to get lost. A couple things to note: if any terms are skipped in either of these, we didn't have that in this problem, but say it went from x cubed to x, you're always going to want to put a placeholder with a 0 coefficient in there. So like if it went from x cubed to x, we'd put a plus 0x squared in the middle as a placeholder, just to ensure that term had a place, because as we do the math, that term could be generated. And same over here, placeholder. It's just useful to keep track of, so make sure nothing gets skipped when we're doing the math. Again, doesn't come up here, but it's an important thing to note when setting up these problems when it does come up. So the first thing we're going to do is we're going to take the first term here, and I'm going to write it over here on the right, that x squared, and I'm going to divide it by the first term of our divisor here. So I'm going to have x squared divided by x. I'm going to solve for that. So I can cancel an x out of each. The solution is x. And I'm going to put that on the top line here. So that is the start of the equation of my asymptote, my oblique asymptote. Then I jump over to the left. Again, you can do this anywhere. I just like to keep these separate so I know where everything is. I just do it in a very formulaic manner. And I'm going to take this x that I just found, and I'm going to multiply it by the quantity I'm dividing by, of x minus 3. So I do that distribution. It gives me x squared minus 3x. This I'm going to take it and put down here in parentheses, and then like any long division, we have to subtract this. I put it in parentheses to trigger in my mind that I have to distribute this negative. So this is going to become a negative x squared. This will be a positive 3x, which turns this into an addition. So now I do x squared minus x squared gives me a 0. If when you do this, this first term does not come out to be 0, you've done something wrong and you need to start over, because the whole point of what we did is to zero out that term in particular. So if we have negative 5x plus 3x, that gives us a negative 2x. We can bring down this plus 2. So for the next step, we're going to take this negative 2x down here. And again, we're going to divide it by the x over here. So when we do that, the x's cancel, leaves us with negative 2. So at this point, we have the equation of our oblique asymptote. It's going to be y equals x minus 2. So that will be our oblique asymptote for this problem. Continuing this problem further to solve would just give us a remainder term. We don't need the remainder term for this application, but if you're doing a full long division, you would keep going and find any remainder terms that are left over. But for the purposes of this problem, that's as far as we need to go. We have our oblique asymptote. So I'm going to flip over to the back here, and here's one you guys can work on for the discussion, and it is find the horizontal or oblique asymptote for the function x squared minus 5x minus 3 over x squared plus 1. So remember the rules I went over for horizontal versus vertical, and good luck, and have a great rest of your day. Thanks. Bye.